In this video we're going to discuss how to divide complex numbers. Before we can discuss how to divide complex numbers, we first need to talk about this idea of complex conjugates. So the numbers a plus bi and a minus bi are what we call complex conjugates. So another way to say that would be two numbers are complex conjugates if they have the same real part and opposite imaginary parts. So the way we've noted that here is that this real part is a for both numbers, so same real part, and then one number has b and one number has negative b for the imaginary parts. Now the thing that's so special about complex numbers is that if we multiply them, we get a real number. And that's not always the case with any two complex numbers. If you multiply any two complex numbers, you might get a real number, you might get a non-real number. But if they're complex conjugates and we multiply them, let's see what happens here. So we distribute the a, distribute the bi, so the two terms in the middle add to 0, and we're just left with the first term and the last term. Now the last term has I squared, which is equal to -1, and so we get a squared plus b squared. So we're not left with I anywhere, which means we have a real number. So this is going to be helpful to us when we divide complex numbers, because what we're going to have is something like this: 7 plus I divided by 3 minus I. So the goal is to write this in standard form. Remember, standard form is a plus bi. So standard form does not have an I in the denominator. That a plus bi, that's all in the numerator. So what we need to do is we need to make our denominator a real number, whereas right now it's an imaginary number. So the way we do that is we multiply that denominator by its complex conjugate, because we know that if we do that, the result will be a real number and we won't have any i's in the denominator anymore. So we know that if we do 3 minus I times 3 plus I, we'll get a real number in our denominator. Now, of course, we don't want to change the value of what we have, so we need to also do the same thing to the numerator. Because then we're multiplying by 3 plus I over 3 plus I, which is 1. And we know that multiplying by 1 doesn't change the value of what you started with. So we're going to do lots of distributing on the top and the bottom here. So if you haven't yet watched the video on how to multiply complex numbers, that is what we're doing here. So we distribute the 7 and distribute the I. And on the bottom we distribute the 3 and distribute the -I. And now we just need to write the numerator and denominator in standard form, which is going to involve combining our I terms and rewriting I squared as -1. Now remember, our goal is to write it in standard form. Standard form is not a big fraction like what we have. Standard form is a plus bi. So we need to fix this so it's not a big fraction. So this would be the same as 20 over 10 plus 10I over 10. And then in this case, we can simplify each of those fractions. So 20 over 10 is 2, and 10 over 10 is 1. So we just get 2 plus I. So now our answer is in standard form. Sometimes the real part of your denominator is 0, and that's okay. You can still do the same thing. So here our denominator is negative 2i. We can kind of think of that as 0 minus 2i if you like. And then we can see that the real part is 0. The imaginary part is negative 2. So the complex conjugate of that would be 0 plus 2i, or just 2i. So we'll want to multiply this by 2i over 2i. So we're going to distribute on the top since the numerator had a plus sign. No distributing necessary on the bottom because there's no addition or subtraction. It's just negative 2i times positive 2i. So negative 2 times positive 2 is negative 4, and then I times I is I squared. Then we need to replace each of those I squared with negative 1. And again, this is not standard form. This is a big fraction. Standard form is a plus bi, so we need to split it up. And one of the reasons for that is because then we can simplify. So I'm running out of room. But this would be negative 3 halves plus 5 halves I. And that's in standard form because it's a number plus a number times I.